Let x1 through x100 be independent, identically distributed random variables such that probability x equals 0 equals probability x equals 2 equals 0.5. Let S is equal to the sum of these variables. Calculate the approximate value of probability S greater than 115. So each of these variables takes on only the values 0 and 2 because we are given that the probability of 0 is 0.5 and probability of 2 is 0.5. And since the 2.5s add up to 1, it means there is no other probability that they take. And so this is just a variable which takes only 2 values. And so we start by tabulating it. Probability of x equals 0.5 equals 0.5 for x equals 0 and also for x equals 2. And the expected value. So remember, we are to calculate the probability of their sum being greater than 115. So this should be done through normal approximation. And in order to do that, we first need to have the mean and standard deviation of each of the individual variables. And then we will use central limit theorem to get the mean and standard deviation of the sum, and then use our normal approximation. So first step is to calculate mean and standard deviation of each of the variables. So mean is the summation of xpx, 0 times 0.5 plus 2 times 0.5, so that's 1. And e of x squared is summation of x squared px, that comes out to be 2. And then variance is e of x squared minus e of x whole square, so 2 minus 1 square. We should write that equals to 1. And the standard deviation will be the square root of variance, so that's also 1. So now we have the mean as 1 and standard deviation of 1 for the individual variables. So by central limit theorem, the sum would be n times mean of each. So there are 100 variables, so 100 times 1 is 100. And the standard deviation of the sum is square root n times standard deviation of each, so square root 100 times 1, that's 10. And since we have to find the probability that the sum is greater than 115, so we need to change 115 into standard score. So mean is subtracted from that 115, and we divide by the standard deviation. And that comes out to be 1.5. And therefore, the probability that sum is greater than 115 is the same as probability z greater than 1.5, which is 1 minus probability z less than equal to 1.5. And from the tables, let's pull out the table. So P tables. So we were looking for 1.5, and that's 0.9332, as you can see from here, 0.9332. And now we go back. So it'd be 1 minus 0.9332, that's 0.0668, and this rounds to choice B. If we look in the original problem, 0.067.